The same storm wave that has been battering the southern plains all week is not done yet. A rapidly building ridge is about to supercharge the atmosphere across the central United States, and the combination of explosive instability, a powerful low-level jet, and back-to-back disturbances rotating through the upper levels means the Great Plains and the southeast are staring down a relentless multi-day severe weather siege that is going to keep forecasters on their toes from today straight through the first week of June. Welcome to Sky Space Lab, I am Arthur. This channel is very new, and every like and subscription truly helps us grow and bring you even deeper, more powerful research. Thank you in advance for every like and follow. Let us talk about what is happening right now in the atmosphere, because the setup we are dealing with today is genuinely complex, and you need to understand the big picture before we get into the day-by-day breakdown. As of this Saturday morning, the Weather Prediction Center has confirmed what forecasters have been watching develop all week. An amplified upper-level pattern has locked itself into place across the contiguous United States, and it is producing a split-flow situation that is simultaneously suppressing major outbreaks in some regions while quietly loading the gun for repeated rounds of mesoscale severe weather in others. Here is what the jet stream looks like right now. We have a pronounced upper-level trough digging aggressively along the east coast, reinforced by waves of shortwave energy rotating out of eastern Canada. That trough is not going anywhere quickly. It is going to sit there, getting reinforced, through at least midweek. On the opposite end of the country, we have a closed mid-level low centered over the Rockies and the northwest, and that system is the key player in today's story. Between these two features, a ridge is building across the interior plains. That ridge is pumping warm, moist air northward out of the Gulf of Mexico, and the dew points across the central and southern plains are currently running in the low to mid-60s Fahrenheit. That is the fuel. That is the unstable, moisture-laden air mass that storms are going to tap into every single afternoon and evening for the next several days. Now, what does a ridge in the plains mean for severe weather? On the surface, it sounds like it should suppress things, and to some extent it does suppress the large-scale, synoptically organized outbreaks, which are the major tornado events you see where an entire region is shut down for a day. Synoptic just means large-scale, the kind of setup where a massive low-pressure system sweeps across the country and drags a sharp cold front with it. That is not what we have right now. What we have instead is a pattern that meteorologists call mesoscale severe weather, and that word mesoscale is the entire story of the next 7 to 10 days. Mesoscale means small scale. It means the atmospheric triggers for these storms are not the giant systems you can see on a national radar map from 100 miles away. They are subtle. A weak outflow boundary sitting just east of Lubbock, a narrow zone of enhanced wind shear over western Kansas that develops in the late afternoon, a capping inversion that breaks suddenly over northern Oklahoma and allows explosive convection to fire within a matter of minutes. These features are genuinely difficult to forecast, and they can catch you completely off guard if you're not paying attention. The Weather Prediction Center's extended forecast discussion from Friday afternoon laid this out clearly. The pattern for the period beginning today and running through at least Friday of next week features that closed mid-level low over the Rockies and northwest gradually weakening and shifting northeastward toward the Canadian border. As it does, it will move along the United States-Canada boundary and keep sending energy southward. Simultaneously, the East Coast trough will eventually retreat northward and back into the North Atlantic by late next week. In between these two dominant features, the Plains Ridge is going to remain anchored. Southerly surface winds across the plains will keep the moisture flowing. Dew points in the 60s and even low 70s across Texas, Oklahoma and Kansas are not going anywhere for days. And aloft, mid-level temperatures will remain cool enough to support steep lapse rates, which is the rate at which temperature decreases with altitude. Steep lapse rates combined with rich low-level moisture and surface heating during the afternoon hours create enormous convective available potential energy, which is CAPE. CAPE is the measure of how much energy is available to fuel a thunderstorm updraft. Values across the southern high plains this afternoon are going to be explosive, and that is the word you should hold on to as you look at the next several days. The Storm Prediction Center's Day 4 through 8 outlook, issued Thursday morning from Norman, Oklahoma, was unusually specific in its language. The SPC noted that for much of the extended period, southerly surface winds across the plains would maintain that moist air mass with 60° and 70° Fahrenheit dew points. In the upper levels, a weak negatively tilted trough is expected to shift slowly northward across the northern plains and Rockies on Sunday and Monday. A negatively tilted trough is a jet stream disturbance that is oriented from northwest to southeast, rather than the typical northeast to southwest. That orientation matters enormously for severe weather because it focuses upper-level divergence, which is the spreading apart of air aloft that helps pull storm updrafts upward over a narrower and more defined area. It also tends to produce stronger wind shear, meaning the change in wind speed and direction with height that allows thunderstorm updrafts to rotate and become supercells. The SPC specifically noted that farther south, into the central and southern plains, upper-level winds will actually be weaker, but mid-level temperatures will remain cool enough over the warm and humid surface air to support areas of strong instability during the peak heating hours. In plain terms, every afternoon this week when the sun heats the surface and lifts parcels of warm moist air into the cold mid-levels above, storms are going to explode. The question each day is going to be whether any organised severe weather mechanism is present to focus those storms into supercells, or whether they just form as scattered isolated cells that produce big hail and wind but stay relatively disorganised. Now let us get into the specifics, because today, Saturday, May 30th, is not a quiet day. The Weather Prediction Centre confirmed a slight risk, which is a level 2 out of 5 on the SPC categorical scale, of severe thunderstorms over parts of the northern and central high plains for today. That risk area covers a corridor that includes portions of eastern Wyoming, the Nebraska Panhandle, and into the Dakotas. The primary hazards associated with today's activity include frequent lightning, severe wind gusts that could top 60 miles per hour in the stronger cells, hail of 1 inch or larger in diameter, and yes, a tornado threat that is real even if it sits on the lower end of the probability scale. Here is what is driving today's setup. That weak negatively tilted trough that the SPC mentioned in their day 4 through 8 discussion is now arriving. It is pushing eastward across the northern Rockies and into the high plains, and as it does, it is providing a modest but meaningful increase in upper-level wind speed and directional change with height. That is the wind shear signature. Combined with dew points in the lower to mid-60s already in place across western Nebraska and south-central South Dakota, and afternoon surface temperatures that will likely reach the upper 80s to near 90 degrees across the southern portions of the risk area, you have the ingredients for at least some organised convection. The timing today is critical to understand. The morning hours will be relatively quiet across most of the risk zone. Cloud cover from any overnight convection will need to burn off, and that cap, the layer of warm air in the mid-levels that suppresses storm development until heating is intense enough to break through, will hold things in check through the late morning hours. By about noon to 1 in the afternoon, isolated convection will begin trying to initiate near the Wyoming-Nebraska state line and southward along the high plains. By 2 to 3 in the afternoon, if the cap erodes enough, which will depend heavily on exactly where the strongest surface heating occurs, you could see some of the first supercells of the afternoon begin to organise. These early storms will have the cleanest environment with the best wind shear, and any discrete supercell that gets going before the rest of the storms begin firing will have the highest tornado potential of the day. That window from roughly 2 to 5 in the afternoon is the one to watch most closely if you are in the northern plains today. Specific areas to be aware of include Rapid City and the Black Hills of South Dakota, the Sand Hills region of western Nebraska near Alliance and Chadron, and the area around Sheridan and Gillette in northeastern Wyoming. These locations sit within or close to the slight risk area, and if a supercell manages to stay discreet and tap into that moist southerly flow at the surface while interacting with the wind shear aloft, a tornado is absolutely possible. I would not call this a high-ceiling day for significant tornadoes given the somewhat limited moisture depth, but the low-end tornado threat is genuine and should be taken seriously. By about 5 to 6 in the afternoon, storms will begin to upscale. This is where the wind threat really ramps up. Individual supercells tend to merge into clusters or linear segments as the afternoon wears on, and once that happens, the tornado risk decreases but the damaging wind threat increases significantly. Bow echoes, which are the bow-shaped radar signatures of fast-moving linear squall lines capable of producing widespread straight-line winds of 60 to 80 miles per hour, are possible during the evening hours across the northern plains. If you live in the Bismarck area or farther east toward Pierre, South Dakota, be aware that a line of storms could arrive during the late evening and overnight hours, with little warning given how quickly these linear segments can accelerate. Now let us shift to tomorrow, Sunday, May 31st, because this is where the pattern gets more interesting and frankly more concerning in terms of potential coverage and intensity. That same weak negatively tilted trough that is providing the upper level support for today's activity will have shifted a bit farther northeast by Sunday, but the real change is at the surface. A quasi-stationary frontal boundary, which the Weather Prediction Center confirmed in their Friday afternoon short-range discussion, is draped across the region, extending from the southern mid-Atlantic westward into the southern plains and then northward into the northern high plains. This boundary is not going to move much on Sunday. It is going to sit there and serve as a focusing mechanism for storm initiation. Frontal boundaries are absolutely critical for severe weather because they create a sharp contrast in temperature, moisture, and wind direction along a relatively narrow zone. When storms fire near or along a boundary like this, they can interact with the boundary parallel low-level wind shear and dramatically increase their rotation. Forecasters sometimes call this process getting into the boundary, and it is one of the most consistent precursors to significant tornadoes. On Sunday, the surface boundary will be positioned across portions of central Kansas, northern Oklahoma, and extending back into the southern plains. That is tornado country. That is the heart of Tornado Alley. And with the moisture in place, the instability building through the afternoon, and this boundary acting as a focus, the risk of organized supercells with all severe weather hazards, including a non-trivial tornado threat, is something we need to be talking about. The SPC has outlined areas of the central and southern plains, including portions of Kansas, Nebraska, and Oklahoma, as having the potential for strong thunderstorms every single day during the peak heating hours throughout the extended period. On Sunday, I would expect the day 1 outlook to carry at least a marginal risk, which is level 1 out of 5, across a broad area, with a slight risk possible if the models continue to show better organisation of storms along that surface boundary. The primary hazards for Sunday will be very large hail, possibly approaching baseball size with the strongest discrete supercells, damaging winds as storms upscale into linear segments during the evening, and a tornado threat that will be highest during that discrete supercell phase in the afternoon hours. Timing for Sunday looks something like this. Storms will likely begin initiating near the Kansas-Colorado border and across the Oklahoma Panhandle between 1 and 2 in the afternoon. The warm sector ahead of the quasi-stationary boundary will be loaded with energy by that point, and any trigger, whether it is the sea breeze-like convergence along the dry line or the approaching upper-level energy from that northward shifting trough, will be enough to punch through the cap and ignite explosive convection. Between 3 and 6 in the afternoon is the critical window. This is when individual supercells will be most capable and most likely to produce large hail and tornadoes. Cities like Wichita and Salina in Kansas, Enid and Oklahoma City, and even Dodge City and Liberal in southwestern Kansas need to be monitoring the radar closely during this window. The Storm Prediction Center will be updating their outlooks throughout the day, and you should be checking those updates regularly. By 7 to 8 in the evening on Sunday, the storm mode shift begins. Storms cluster and organize into a squall line that will push eastward across Kansas and Oklahoma into the overnight hours. The severe hail threat diminishes as the line consolidates, but damaging winds of 55 to 70 miles per hour become the dominant threat. That line will continue pressing eastward through the overnight hours, possibly reaching the Missouri-Arkansas border region by the early morning hours of Monday. Flash flooding concerns will also accompany this overnight activity, given the already saturated soils across much of the southern plains and lower Mississippi Valley. The flooding concern is not an afterthought in this pattern. It is one of the most serious secondary threats running parallel to the severe weather story for the entire period, and we need to spend real time on it before we continue into the extended forecast. The Weather Prediction Center issued a slight risk of excessive rainfall for portions of the middle and lower Mississippi Valley, the Tennessee Valley, and the southeast for Friday, and that same risk area effectively carried forward into the weekend. The soils across the Dixie Alley region, covering parts of Mississippi, Alabama, Arkansas, and Louisiana, are already saturated from repeated rounds of heavy rainfall over the past several weeks. When soil is saturated, it cannot absorb additional rainfall efficiently. Water that would normally percolate into the ground runs off immediately into streams, creeks, and drainage channels, and those waterways fill and overflow far faster than residents expect. What this means practically is that even a storm that drops only 1 to 1.5 inches of rain in 30 minutes which is a relatively common outcome from a strong pulse thunderstorm in this environment, can produce flash flooding in areas where the same rainfall 2 weeks ago would have caused no problems at all. The Weather Prediction Centre's extended discussion from Friday afternoon specifically highlighted the presence of anomalous moisture anomalies running in the 90 to 90th percentile range across portions of the region, meaning the amount of water vapour in the atmosphere is near the top of the historical record for late May. That atmospheric moisture does not just fuel intense thunderstorm updrafts. It also means that when rain falls, it falls heavily and quickly. For the specific cities and regions that need to be most alert to flooding through the first several days of June, the list includes Baton Rouge and New Orleans in Louisiana, where widespread rainfall totals of 4 to 7 inches are possible across the period. The lower Mississippi River corridor has very little additional capacity for runoff right now. Mobile and Pensacola in the Florida Panhandle region are looking at similar totals. Memphis, Tennessee, and the surrounding area sits in another zone of elevated concern, as does the stretch from Jackson, Mississippi, northward toward Tupelo and Corinth. Farther west, Dallas and Shreveport sit in the transitional zone where thunderstorm activity will be most frequent, and localized rainfall totals of 2 to 4 inches are possible in any single storm event, particularly if storms stall or train over the same area repeatedly. The southeastern corner of the country is simply going to remain wet for the foreseeable future. The pattern is not changing quickly enough to dry things out, and every new round of storms adds to the accumulated total. If you live in any of these areas and you hear a flash flood watch or warning, treat it with extreme seriousness. More people die in floods each year in the United States than in tornadoes, and the reason is almost always the same. People underestimate how quickly water rises and how little depth it takes to sweep a vehicle off a roadway. 6 inches of fast-moving water can knock a person off their feet. 12 inches can carry a small vehicle. Do not drive through flooded roadways. Turn around. Do not drown. Now let us move forward into the hour-by-hour breakdown for what I consider the most significant weather day of this entire forecast period, which is shaping up to be Monday, June 1st. Monday is when the pattern alignment is most favourable for widespread and potentially impactful, severe weather across the central and southern plains. The upper-level low that has been centred over the Rockies and northwest during the weekend will have weakened somewhat by Monday, but will still be present as a diffuse area of low pressure over the northern Rockies. As it shifts northeastward toward the Canadian border, it will send a shortwave trough, which is a smaller embedded disturbance within the broader upper-level flow, diving southward across the central plains. That shortwave is going to interact with the surface boundary that has been sitting nearly stationary across Kansas and Oklahoma since Sunday. By early Monday morning, the remnants of Sunday night's squall line will be weakening as they push into Missouri and Arkansas. The line loses its punch as it moves away from the source of instability and moisture to its west. Behind the line, things quiet down across Kansas and Oklahoma for a few hours. The atmosphere recharges. The sun rises, heating the surface rapidly, and that already moisture-laden air mass begins destabilizing again from the ground up. Cape values will be rebuilding across the entire warm sector by late morning. By about 10 to 11 in the morning, the first subtle signs of the day's convective potential become visible on high-resolution model output. The dry line, which is the boundary between the hot, dry air coming off the high terrain of eastern New Mexico and Colorado, and the warm, moist Gulf air to its east, will be pushing eastward across western Kansas and into the Oklahoma Panhandle. The dry line is one of the most important and most underappreciated features in American severe weather meteorology. It acts as a convergence zone where the dry and moist air masses meet and lift, providing the initial trigger for storm development. On Monday, that dry line will be sharp and well-defined, oriented roughly north to south from near Dodge City, Kansas, southward through Liberal, and into the Oklahoma Panhandle near Guyman. Noon to 1 in the afternoon is when the cap begins to erode along the dry line. Surface temperatures by this point will be in the low to mid-90s Fahrenheit across the warm sector. The combination of surface heating and the approaching shortwave trough aloft creates enough upward motion to finally break the cap, and the first towers begin punching through the tropopause near the dry line. These are your first storms of the day, and they are the most dangerous ones. They initiate in an environment of high CAPE and strong wind shear, with no other convection nearby to interfere with their updrafts or contaminate their inflow. These are the textbook discrete supercells. Between 1 and 2 in the afternoon, the first supercells are fully organized over western Kansas and the Oklahoma Panhandle. Large hail will be the initial dominant hazard, and I am not talking about quarter-sized hail here. The thermodynamic environment on Monday is favourable for hail in the 2-inch to 3-inch range, which is golf ball to baseball size, with any storm that sustains a strong rotating updraft for more than 20 to 30 minutes. Baseball-sized hail can shatter windshields, dent metal roofing, strip the bark from trees, and cause tens of thousands of dollars in property damage in minutes. If you live within the threat area and you see a tornado watch or a severe thunderstorm warning with a particularly dangerous situation designation, get your vehicle into a garage or under solid cover immediately. Between 2 and 4 in the afternoon, the tornado threat peaks. This is the window where the low-level jet stream, which is a ribbon of fast-moving southerly wind in the lowest few thousand feet of the atmosphere that typically strengthens in the afternoon and evening across the plains, begins to crank up significantly. The low-level jet is critically important for tornadoes because it provides intense directional wind shear right near the ground, which is exactly where tornadoes form and intensify. When you have surface winds from the south or southeast, and winds at about 5,000 feet already backing from the southwest, you create a strong rotational tendency in the lowest levels of any supercell. Couple that with the strong mid-level wind shear from the approaching shortwave trough, and you have a recipe for significant long-track tornadoes. The cities I am watching most closely for Monday afternoon during this peak window include Dodge City and Liberal in southwestern Kansas, Woodward and Enid in northwestern Oklahoma, and the area around Amarillo in the Texas Panhandle. These locations sit squarely within the zone where the dry line, the surface boundary, and the best wind shear all converge. If a supercell develops in this area and remains discrete, meaning it does not immediately get absorbed into a cluster of other storms that would disrupt its organized updraft structure, the conditions are there for a potentially strong tornado. I want to be clear that I am not forecasting a catastrophic outbreak here. The mesoscale nature of this pattern means the organization is going to be imperfect, and the ingredients will not all come together simultaneously everywhere. But the ceiling is high enough that significant tornadoes cannot be ruled out, and the Storm Prediction Center's outlooks for Monday are going to be worth watching very closely as the day approaches. By about 5 to 6 in the afternoon, new storm development begins firing farther east along the quasi-stationary surface boundary, across central Kansas and into southern Nebraska. These storms have slightly less cape to work with than the western cells, because the boundary layer has been mixing more, but they still have good shear support. Wichita, Salina, and the Hutchinson area in central Kansas fall into this secondary initiation zone. The tornado threat with these eastern storms will be slightly lower than with the western dryline supercells, but wind and hail will remain a concern. By 7 to 8 in the evening, the storm mode transition begins. The discrete supercells to the west begin merging. An outflow boundary, which is the pool of cool air pushed out ahead of a storm's rain-cooled downdraft, spreads eastward from the convective complex, and new cells firing along this outflow boundary rapidly become linear. A bow echo segment develops, and the primary threat shifts decisively toward damaging straight-line winds. Wind gusts in the 55 to 75 mile/hour range are possible, with the most intense bowing segments. The Kansas City metro area and the Wichita urban corridor will need to be on alert during this window, as the squall line will be tracking eastward through these population centers during the evening hours. Power outages from widespread wind damage are a real possibility, and because these linear events often arrive after dark when people may not be monitoring the weather, notifications on your phone are not optional tonight. Make sure your wireless emergency alerts are enabled. During the overnight hours from Monday into Tuesday morning, the squall line will continue pressing eastward into Missouri and possibly into the St. Louis metropolitan area before sunrise. The wind threat remains the dominant hazard with a linear system at night, and occasional embedded supercell structures within the line can briefly rotate and produce short-lived tornadoes even in the overnight hours. These are called QLCS tornadoes, or quasi-linear convective system tornadoes. They are usually brief and weak, but can still cause damage, and they are notoriously difficult to warn for because they form and dissipate quickly within the context of a moving line, rather than as obvious isolated supercells on radar. Into Tuesday, the pattern essentially resets. The instability rebuilds during the afternoon heating hours across the southern plains. The surface boundary that has been the focus for storm initiation since Sunday is still draped across the region, having not moved much given the broader synoptic stagnation. Tuesday's setup will look similar to Monday's in broad strokes, though the specific details will differ based on exactly where the overnight convection left its outflow boundaries and exactly how much destabilization occurs before the next round of afternoon storms fires. The Weather Prediction Center's extended forecast discussion from Friday afternoon specifically mentioned that the closed mid-level low over the Rockies and Northwest will push east along the United States-Canada border as the week progresses. This is important because it means there will be a continuous supply of shortwave energy rotating around the periphery of that system and diving southward into the plains throughout the week. Think of it like a carousel. Each shortwave disturbance that rotates around the larger system provides a new pulse of upper-level support for storm development. Monday's shortwave gets followed by another one on Tuesday, then another on Wednesday. This is why forecasters are talking about severe weather potential every single day across the plains through the end of the first week of June. Wednesday and Thursday deserve specific mention as well, because the European Centre for Medium-Range Weather Forecasts, otherwise known as the European Model, has been signalling something potentially more significant developing by Wednesday into Thursday. The European Model has been consistently showing a more amplified trough digging into the central United States by midweek, one that would bring stronger upper-level wind speeds, a more defined surface low-pressure system, and a more organised severe weather setup than the mesoscale events dominating the earlier part of the week. If the European Model verifies, Wednesday into Thursday could represent a significant upgrade in the severe weather threat, potentially reaching enhanced risk, which is level 3 out of 5, territory across parts of the Central Plains. The American GFS model, the Global Forecast System, has been less aggressive with this midweek amplification, but has not fully dismissed it either. There is genuine model disagreement here, and that disagreement is telling us something important. The pattern is sensitive to small differences in how the Rockies low evolves and how quickly the energy ejects eastward. A slight shift in timing, or in the strength of the trough, could be the difference between another mesoscale day and a more organised, higher-impact outbreak. This is exactly the kind of uncertainty that the Storm Prediction Center was referencing when their extended period products highlighted predictability concerns through the midweek timeframe. I would expect the outlooks for Wednesday and Thursday to be volatile over the next 48 hours, with potential upgrades coming as the models converge on a solution. Looking at the 7 to 14-day picture, AccuWeather's summer 2026 forecast has highlighted June and July as a period of near to above-average severe weather potential from the plains to the east coast, with El Niño developing and strengthening through the season. The development of El Niño, which is a warming of the central and eastern Pacific Ocean surface temperatures, is going to have increasing influence on the jet stream pattern as summer progresses. In its developing phase, El Niño tends to keep the jet stream more active and keeps the storm track relatively close to the United States rather than being pushed far to the north into Canada, as often happens during neutral or La Niña summers. What that means for the severe weather season is that the fuel source for repeated storm systems is not going away. The door remains open for active severe weather periods throughout June, and the second half of June in particular is one window that both the GFS and the European model have been tentatively flagging as a period of potentially renewed large-scale severe weather activity. The flooding picture through the rest of this week and into early June deserves one final direct statement. The Weather Prediction Center's quantitative precipitation forecasts show widespread rainfall totals of 1 to 4 inches expected across the southeast, with locally higher amounts of 5 to 7 inches possible in portions of southern Louisiana and the Mississippi Gulf Coast region between now and Sunday. These are not 7-day totals for dry ground. These are 7-day totals on top of ground that is already holding essentially as much water as it can. The flash flood threat in these areas is elevated and persistent, and it is not going to resolve until a drier pattern finally breaks the current wet regime, which the models are not showing happening quickly. If you live in the Gulf Coast region, the lower Mississippi Valley, or anywhere in the southeastern United States right now, your flooding awareness needs to be as elevated as your severe weather awareness. Have a plan for both. Know your local flood-prone roads, know where the nearest elevation is, have your weather alerts enabled and your phone charged. The severe weather side of this pattern is the part that gets the headlines, but flooding is quietly the deadlier threat, and this pattern is delivering both simultaneously. Thank you so much for watching today's forecast. If you are new to Sky Space Lab, hitting that subscribe button right now genuinely makes a difference for a channel this new, and it makes sure you do not miss a single update during what is shaping up to be an extremely active start to June. We will have another video up as soon as the models sharpen on that midweek development, because if the European solution verifies, we're going to have a lot to talk about. Keep your eyes on the sky, keep your alerts on, and stay weather aware out there.